Hello everybody, this is my write-ups for the LITCTF 2024. Will be all web. Um, in my opinion, I kind of did bad on the CTF, not really good, but I had some fun here and there. So let's get started. So the first challenge will be web inspect, anti-inspect. So it says, can you find the answer? Warning, do not open the link, your computer will not enjoy it much. If you open it, it'll just crash your browser. So what we can do is we can just, yeah, we'll just cancel that out. What we can do is we can just simply just curl, oops, you can just curl the link. So let me just copy link address. And we get our flag. Um, you might have, my teammate told me you might have to remove the percent character, but yeah, nice. Alright, so for the next challenge, it's JWT-1. It says, I just made a website since cookies seem to be a thing of the old days. I updated my authentication. With these modern web technologies, I'll never have to deal with sessions again. So we'll try out the link. I'll try it out in this browser, Firefox, because when I was trying it out on Google Chrome, there's just some weird things that were happening that impeded on the original solve that I did. So we have a login prompt and a get flag, but if you want to check out get flag, it just says unauthorized. So let's log in. So let's type in, let's just sign up. I believe I already had an account, so if I just sign up, and it says unauthorized. So since this said JWT, or the challenge name says JWT, what this hints towards is the JSON web token, which is a way to basically authenticate you and to prove that you are who you are in terms of like a web service. Like when you log in, like it's like the popular thing with cookies, like how they know who you are and have your name and all that stuff. So if we inspect here, we're able to find storage and we're able to find our cookie or our token. So if we go to this website, jwt.io, and it says where are the JSON tokens, if we go to the JWT debugger and we paste this in, it basically shows everything. And since they don't give us the source code, we basically have to assume that they don't verify the signature. So what we can do basically is just turn this to true, copy this, go to get flag, and then we just change this here and update, and there we go. We get the flag. Cool. Nice. Okay, so the next one is JWT-2, and it says it's just like JWT-1, but this one is a little harder. Okay, so if we go to the website that they provided to us, it's the same thing. It's unauthorized, but with the winky face, I guess. We can log in, so if you just need to sign up if you don't have an account, so let's sign up. And it says you can't do much to log in, unauthorized. So let's take a look at this token again. We just copy and paste our token, paste it back into the JWT.io just like last time, but they provided a source code, and it says it's a little bit harder, so we need to analyze what they're doing. So luckily, let's read the source code. So they go through everything. Oh, this is something very nice. This is the JWT secret, which is Zook, which we definitely need. And if we see here, it signs. And basically what it just does, it just signs a JWT token. If we go to the flag, here the unauthorized, and what it does, believe it verifies the signature here. And if it doesn't verify it, then it says unauthorized. So what we need to do is basically, we need to forge our token, and in order to make it legit or pass this check, we just need to copy this here, go here, change this to true. Because what happens is if we don't verify the signature with the secret key or the secret, the JWT will be invalid, and basically this check will fail, and it won't be a legitimate token that we can trick the website into using. So if we just go to inspect here and we change this cookie, we go back and reload, and there we go. We get the flag. Hi, so the next challenge is web traversed. It says I made this website. You can't see anything else though, right? URL http litctf.org, and so Based on challenge, it's a based on the challenge name, it's a path traversal, which basically means we can just go up the root directory and try to solve it. So after doing a bit of fuzzing, I was able to understand that if you do this, you're able to get the etc/shadow, which is basically a file that stores the users and their associated like things. It's basically just to prove that I could do it. So what I did next was to do proc/self/environ, and it downloads the environ variable. So what this will do is this will just give us a little bit more information about like what the environment, like what's in the Docker container. So if we just open it up and we open up that environ, this shout out to my friend Musir. He was able to download and share the information which helped solve this. So if you go down here, you can see there's a bunch of paths here. It was a bit corrupted when I opened it up on my thing, but I don't know why on my teammate it didn't work like that. But so if we go here, we see /apps. So that'll basically just give us the hint that we just need to go to /app/flag.txt, and we go there. So we get the flag. Nice. Okay, so the final challenge is called or the final challenge I could solve is the web/kirbytime. So it says welcome to Kirby's website. So let's just read the source code provided to us. So if we just read this, so we have basically a web app, and it says if we send a post request with the password, and the real is obviously redacted, it's not shown. So if the length of the password is not equal to 7, it'll say you'll need 7 cars, so it'll immediately return to that rendering template. So, but if there is a 7, if it is 7, it'll iterate through the length of the password, and if the index of the password if the character in the index of the password does not equal the character in the index of the real, it'll give us out a message incorrect and return immediately, which will terminate whatever search we were doing. So this else, which is time.sleep, is basically a blind indicator of whether we have the correct or incorrect character for the password. So what we can do is, as we iterate through the length of the password and try to brute force this, we'll go step by step and basically just try to keep up with the time. So if we're starting off, we'll try to account for 1 second, then we'll account for 2 as the character length increases, because it's based on each index of the character for the time.sleep. So I made a small script. You might have to start off with an empty password string as well as a different password length, but since the instance for the time is really like it's really slow, it's really a little too little to actually solve through. I'll basically just show off that this solve script works. So what it does is it gets all possible printable characters that I believe would only be printed there, so it gets rid of all this mostly special characters. It'll basically just verify and try stuff. It'll try out this temp password basically, which is just the character of the password plus the character we're trying to test with, and then whatever garbage we need just to terminate immediately. So so it'll just start off, and it'll start with the time, and then it'll read a response, and basically I'll have to modify this. So it'll basically, if the round elapsed time is greater than or equal to the next length, then we can just add this to the password, and we can break and go on to the next length, next index of the password. So let's just start at the instance, and this might take some time, so I might just reveal the flag. So let's just run this real quick. Okay, after some time passed, we were able to get the password, which is KBYSLAY. Input it into the the website, and we'll just verify that is the correct password. So let's just open this new tab, and let's just place this here. It'll take a while since it's verifying everything. Let's see. And it says, "Yay, hi Kirby." So it means that our password is equal to real. So we have our flag LITCTF KBY slay. Nice. So this is all the challenges I could solve. Thank you very much. Bye.